right. I'm just going to share my whole screen. All right. So can everyone see?
Yes, I can see.
All right. So before I talk about the assignment, I'm going to explain a few things about pointers and pointer arithmetic. I'm going to walk you through this whole program I wrote, and then I'm going to add a few more things to it, just so that you'll understand what's going on and what will need to be done in certain parts for this assignment. So this program starts out, we declare two variables. An int is called size, it starts at a 0, and another int pointer that is set to null pointer. So I loop and get a size that's greater than 0. And when I get that size, I use that size to allocate buffer to a new int array. And then in a loop, I populate that array with various multiples of 10. Is everyone following along so far? All right. And so I print the buffer using the standard way we've known to print an array, by using the name of the array and followed by brackets and either a letter or a variable inside, or a number or a variable inside that shows you, that is telling the array what index needs to be accessed. And then at the end, I delete the buffer and then set it to null pointer. All right, I'm just going to run it just to let you show how it works. So the program actually runs. It says, all right, enter a size. I give it a size of 10. And it populates the array with multiples of 10. And then here, it says, print the buffer. It's printing the buffer the way we've always known how to print an array. You access an array using the name of the array, followed by two brackets and a number in between the brackets. This is all stuff that we've all that you've all been taught, you've used for assignments before, correct? But for this assignment, you're going to need to use pointer arithmetic. And when an array is made from a pointer that is dynamically allocated, there are a couple of different ways that you can access the array. So one way I'm going to show you what's known as pointer. I'm just going to explain it to you in English. I'm going to show you how to take a pointer and get the value of that thing that is being pointed to. So we already know that buffer is really just a pointer. I made a pointer and I said, hey, C++, take this pointer and make it into an array of this dynamic size. And because it's still deep, C++ is still treating this as a pointer, I can do this. I can just say cout buffer. And all right, well, what's this? When you have a pointer and you put an asterisk in front of the pointer's name, that's saying, go to that pointer, go to the thing it's pointing to, and then bring back that value. So if I run this again, So it prints the index. All right. When it gets to this line of code of print the thing that the pointer is pointing to, it prints 0. Well, what's happening? Well, remember, this is a pointer. So this pointer is pointing to all of this, but specifically, it's pointing to the first thing inside of it. So when I tell the pointer, go to where you're pointing and bring me back the value, it brings back this 0. Because the pointer is pointing to this whole array in memory, and the very first value is 0. Does everyone following along? If you don't quite understand, just feel free to ask questions or ask me to explain it in a different way. All right. Now this pointer is more than just a pointer, all right? So it's an array and a pointer. Well, what does that mean? Well, it means we can use the this this pointer dereferencing operator of the asterisk in a special way, kind of unique to dynamically allocated arrays. So I can say, all right, I can say more than just I want you to go to this pointer and I want you to get me the data at the pointer. I can say go to the pointer and then go to the location this many steps ahead of it. So I can say, more specifically, go to the location of this pointer plus 1. And what that actually looks like when it runs, let me fix this. Just a little bit clearer to see. So when we go down here to this print statement, first it says, all right, print the value held at where this pointer is pointing to. Then it says, print the value at the location of this pointer plus 1. So altogether, it's print the value that's held at this location, then print the value held at this location plus 1. And well, what does that actually mean? Well, the pointer itself points to 0. Remember, it points to this whole array. So if I say print the thing pointing to this pointer plus 1, it prints the thing that is next to it in the array. Because remember, arrays is all data that's right next to each other. Everyone understand what this means? Feel free to ask me any questions because it is going to get a little bit more complicated from here on out. All right. So what does this mean exactly? So what this means is that, let me go down here. I can take this exact same like loop structure. Where we go through I less than size, I++. And I can print the buffer. But using pointer arithmetic, I can print it in a slightly different way. I can write the, pointer like dereference operator, and then I can say print the location at buffer at this pointer plus this variable. And when these loops happen, the output of these loops is exactly the same. Because saying using the buffer, using the pointer like an array works the exact same way as saying dereference get the data held at where the pointer is pointing to plus this number. Does everyone understand exactly what's going on right here? All right. So there is a third way that we can access stuff inside this buffer, inside this pointer. So because it is a pointer, and because we have this, and a pointer is just pointing to something in memory, I can say make another pointer and have it point to the same place this is pointing to. I can say create this pointer, have this pointer point to this, and then while this pointer is less than while this pointer does not go past this pointer plus the size of the array, the size that has been allocated, keep making this pointer step forward. I can say, all right, print this pointer. I'll make this a little bit. All right, so before I run it again, I'm just going to walk through this. So this second loop is saying create a pointer and have this pointer point to the location that this pointer is pointing to. Have these two pointers point to the same place. Then while this pointer does not go past this pointer plus the size that has been allocated for the array, keep stepping the pointer forward. And each time, while that's happening, print the value held at where this is pointing to. And what that does is it does the exact same thing that the other loops did. So this one I'm going to walk through because it's a little bit more complicated. So we start when the loop starts, this is what happens the very, very, very first time this loop runs. It says, all right, first time this loop runs, create this pointer and set it equal to that pointer. So they point to the same place. And then it starts the loop, says, all right, print the data being held at where this is pointing to. So it prints 0. Then increment the pointer, make the pointer step forward, and then check that we haven't stepped outside the space that has been allocated for the array. We haven't yet. So go back here and print the data that this is the new data that this is pointing to. Then go back, make it step forward, and then check we haven't stepped outside the boundary that we have allocated for the array. And then print the data that is being pointed to. And rinse and repeat until the pointer has stepped outside of this boundary. We've gone past the data that we've allocated. Does everyone understand what exactly is happening? If you don't understand what's happening, you should probably ask now, because you're going to need to be doing a lot of all three of these for assignment 7.
I have a question. Why is it buffer plus size and not just size?
Okay, the reason why it's not size is because I'm going to have to tell you a little bit about like actual computer hardware. So let me print buffer here. All right. So we printed this line. This is the line where we printed buffer. All right. Well, what do all these numbers mean? This number is a physical location on your computer. This number is where the array starts physically. And the reason why you need to say buffer plus size is because you need to know this location, this physical location, plus the number of elements that have been allocated. So it's plus size because we specifically need to say make pointer start at this memory location, and then when we go past this physical memory location, stop. In fact, I can do, I can just illustrate that right here. So as we can see, this is where the buffer starts in memory. And this is the physical spot in memory where the array ends. And I know this seems a little bit complicated, but just understand with the pointer, with this, have the pointer point here and have it stop here, you're kind of trading in the idea of start at 0 and count to a certain amount with the start at this address and then end at this address. Does everyone understand what this means so far?
Yeah, that makes sense. Thank you.
All right. And one more thing I'm going to show is now this loop here where we set the value. I'm going to rewrite this loop. So before, we used an index I that went through the array like normal using the bracket indexing. So for this, what I'm going to be doing is I'm going to be using the dereference operator on this pointer. I'm also going to have to manually take int I and have it manually loop through a different I. But anyway, this loop where we set everything to a multiple of 10 is still the same, but I'm using the looping formula for when I did this purely using pointer arithmetic. Only now I'm saying dereference this pointer and instead make the value at that location be I times 10. And when that runs, the loop ends up looking exactly the same. Because what it's saying is, do the same loop as before. Start out at this memory location. Loop while we don't go past this memory location. But on the inside, I said, at this, where this is pointing to, put this value there. So dereference this, and then make it equal to this. So even though this is not explicitly saying like buffer I equals whatever, it's still the same, because what it's doing is it's instead of saying, all right, make it be array index I equal to this, we're saying grab the literal location on the computer in your memory and put this value there. Is everyone following along so far? Because I'm about to start talking about the homework assignment, which is going to be a lot more of this. All right. All right, so before I start actually talking about the assignment, I'm going to try to illustrate roughly what the assignment is doing. All right. All right. So what we have is we have a buffer. So let's say this is an array in memory. So for our R buffer, we have three important values. We have buffer P, which I'll just call B. We have write P and read P. These are all pointers. So buffer just points to the whole list. Buffer is the entire array. But write and read are different. So when they start out, they both point to the same place as buffer P does. They both point here. But as things are written to the array and read from it, these pointers will move forward. So if the write pointer writes something to the first location, it will say, all right, now move me forward and write here. And same thing, if the read pointer reads something from that location, says, all right, move the read pointer forward and then write something there. And this cycle of either write something to the buffer or read something from it continues, and each pointer moves forward. And they keep moving forward and forward and forward until any one of them points to the last location. So this is pointing to the final thing in the array. And when this writes something here, it can't go forward because there's nothing left in the array. So when the write pointer writes to here, or if the read pointer reads in the last location, the pointer stops pointing to the last location and it loops back around to just printing to buffer again. So the cycle of write/read to this index, move forward, repeat until we're at the end, and then point back to the buffer is going to be essentially what this whole class and what this assignment is about. It's all about using pointer arithmetic to pull off this whole thing inside of a class. So for the constructor and the copy constructor, they're very similar. So if new size is less than 1, set size to 8. Else set size to new size. And size is just the size of the buffer. So empty is a class variable, and it's true if the buffer is empty, if there's nothing inside of it. And set full to false. Because when the buffer is first created, it's going to be empty because there's nothing in it. And if there's nothing in it, then it's not full. So by default, when the buffer is first created, empty will be true and full will be false. After that, allocate buffer P to a new T array of length size. So basically set buffer P to a new T with brackets. And it'd be of length size. And then loop through the buffer however you want to loop through it and set everything in the buffer to 0. Then set read P and write P to buffer P. Because both of these need to point to the buffer. Now for the copy constructor, where the big thing is we're copying all of the data from this so that we want the current class, the current object, to basically be an exact copy of this, the buffer that's being passed. So deep copy, which means just copy each variable over from RHS to the variable inside of this class. Do that except for buffer P, because you want to allocate a buffer P to a new T array of length size, and then you want to copy all of the RHS buffer P into buffer P. Because the copy constructor is supposed to make the current object be a perfect copy of this. Everyone following along so far, if there's something you don't quite understand or want me to explain better, feel free to ask now.
Yeah, can you hear me?
Yes.
So when we're copying over the values, we're going to have to copy where the read and write pointers are at, right? Or where they're like pointing to, right? To the
Yes.
The new one? Okay. All right.
All right. All right. So for the destructor, it's pretty simple. If buffer P is not null pointer, delete it, set size to 0, empty to true, full to false, and set all pointers to null pointer. So for write, this is where we have to start using some pointer arithmetic. So if buffer P is null pointer, just return, because that means the array hasn't even been allocated. And then set the value of what write P is pointing to item. So this is item. And then set empty to false, because if something's written into the buffer, then it can't be false. So if write P is at the last index, meaning that we are at the end of the array, set full to true, and then loop back around. Set write P to buffer P. Else, just increment write P. Have write P step forward. So once again, this function is saying we want to take this item and we want to actually write it to the location here. And then we want to check if we're at the last index, loop back around to the beginning of the buffer. Else, step forward. Everyone understand this so far?
So is buffer P always going to be pointing to the first element? Is that why you would set it to buffer P for it to loop around?
Yes. So when you allocate a pointer to a new array, what is actually happening is that pointer points to the very first element in the array.
All right, thank you.
All right. So onto the read function. For read, if it's empty, throw cannot read from an empty buffer. And throw is the syntax for throw pretty much looks exactly like this. Throw, then text. And throw is essentially an exception. It means something's wrong and we want to handle it with more than just a cout statement. But importantly, the actual reading and writing, the reading is a little bit more complicated than the writing. So if the read and write pointers point to the same location, they point to the same thing, and the read pointer is at the beginning. Let me illustrate this. So here's the buffer. Here's write. Here's read. What we always want to do if they're matching is we want to print the very last thing that we read. You want to print what was before this, but there's nothing before this because we're at the very beginning. So instead we say, all right, if they match and they're at the beginning, return the last index of the array. Because if they're at the beginning, then the last thing that was read was the last thing that's in the array. And if they're equal, so if they're equal, but they don't print to the first element, then just print the thing that came before the read pointer. So if they aren't equal, if they're pointed to two different locations, then declare a temp t that holds this value. And then once the temp t is holding this value, you want to check, all right, is read P at the last index? Is it pointing here? And if so, move it back to the beginning. Have it set to the beginning of the buffer. And in our case, it isn't. So else I'll have the pointer move forward. So read is pointing here. And then return the temp. Oh, sorry. So does everyone understand this, or does someone need me to explain it differently or explain something more specifically? All right. So the resize function is probably the biggest function that will have to be written. So for this one, you want to know the distance of the read pointer and the write pointer from buffer P. And we also want a temp T, a temp array that we're going to use as this is going to be the resized array. So if resize is less than 1, if the new size is less than 1, return false, because it's not valid. And if the new size is the same as size, return true, because there's like resizing an array to the same size just means do nothing. Now, if the resize is less than size, if it's less than the new size, but the buffer is full, return false, because the array cannot be resized. It's full, and we can't erase anything. So we want to get the write distance and the read distance, which is the distance from these pointers to the beginning of the array. Now, if res is less than the write distance, so if we want to resize the array, 1, 2, 3, 4, 5. So let's say this is W. All right, so W is pointing here. So this is the distance. But let's say resize says, well, I want to resize it to this. Well, that can't be done because these have been written to, and resizing the array to this will clobber all of this. So we don't want to do that, and we want to return false saying that it couldn't be done. But if all that's good, set temp to a new T array of length res, and then initialize everything in temp to 0. Does everyone understand so far? All right. So if we want to make the buffer smaller, then what we want to do is we want to take every index between buffer P and write P, and we want to copy all of those indexes, everything in there, to temp. So once again, let me try to illustrate this. So this is our old array, but this is our new one. It's only 3. So let's say that the write pointer is pointing here. It's like 1, 3, and then something here. It doesn't matter. So we're saying, all right, from everything from here to here, copy it over. And so it's saying, all right, copy this 1 over, then copy this 3 over. And because this whole array has been initialized to 0, there's already a 0 in this block. So everything's been copied over. Delete buffer P. So take this and just delete it. Completely clobber it. We don't need it. And then set read p. Let's say the read pointer is here, equal to the distance of buffer p plus read distance, which will take the read pointer and have it point to the same location in this array. And then if the write distance equals the new, if the write distance, the distance between the write head and the read, the write distance in the buffer, equals the new size. So if it should be pointing here, or if it should be pointing here, set the write pointer to here. Set it to write distance -1. So move it back 1. Or, I'm sorry, I messed up on this. So when I said we want to copy everything in buffer p, but before write p, we actually only want to copy this, because the write pointer is something that has not been written to yet. So when we copy the new array over, we want to take this, copy it, and then not copy this. And then we want to delete this. And then have buffer point to here. So what we want to do is we want to set the read pointer, which we'll just say is pointing here, equal to this plus its original distance. So the read pointer will point to here again. It won't point to there, because this has been destroyed. Now for the write distance, if the distance between the write pointer and the read pointer was here, like if the pointer should be pointing here when we set the distance, we want to move it here instead. So if the write distance equals the new size, set write p equal to buffer p plus the distance -1. Else, in our case, just set it to the distance plus the buffer and set size to the new size. Everyone understand this so far? All right, moving forward. So if the new size is greater than the old size, that's pretty trivial because we're taking an array. It doesn't matter what's been written to where in the array, or where the write pointer is, or where the read pointer is. We want to make the new array that's bigger. So it doesn't matter if where these are pointing to, because the array is bigger, we're not going to possibly lose any data. Nothing's going to get clobbered. So actually, let me have these point a little bit further up. The write pointer point here and read point here. So if res is greater than size, just copy everything. So 1, 4, 8, 2, 6. Just copy everything over. Doesn't matter what's in here. Doesn't matter if we want to state it or not. Just copy everything. Then delete this. And then set buffer p to here. So I have buffer p point here. Now, if the right distance equals size minus 1. So if the right pointer was pointing here, then that means that we want to set it to the right distance plus 1. We want to move it forward. So when we actually set it, we want to set it to here. So if right distance equals size minus 1 for the last index, then set the right p to the buffer p plus the distance plus 1, so move it forward. Else, just move it over, and it wasn't pointed to the end in our case, so just set it equal to the buffer plus the distance. And for read, just set it to the buffer plus the read distance. Set size to res and set full to false because this extra data has not been written to yet. And then just return true. So this is inside of an if statement. Like this is its own thing. And then return true is just at the end of the function. Does everyone understand this? All right. So for the clear function, what this wants to do is clear the array of everything and kind of reset it. So declare a new type T array temp and set it to a new array. Allocate everything in the each index in the new temp array to 0. Then delete buffer p. So I'll try to illustrate it like this. This is some array. There's read, there's write. And here is temp. 1, 3, 5, 7, 9, 30. So we create a new temp and allocate it to the same size as the last array. Then we loop through and we make everything at 0. And then what we do is you delete buffer p, so delete this. And then you can set full to false, set empty to true, and then set buffer p to point there, and then have the read and write point to here again. I'm going to be honest, you could probably do this a lot more efficiently than I did when I did this assignment and just say, take this array, set everything to 0, and then move everything to the beginning. I'm going to be honest, I just kind of tried it this way on instinct, and it worked when I ran my own sample. Anyway, is there anything about this assignment or this function that you need me to explain better? All right, so the final function is join. And what join does is it takes two buffers and it combines them into one buffer that is the size of both. And then combines everything that is in them. To actually keep this up. So for this one, you want an int you want a new size that equals the size of both buffers combined. And you want to create a new buffer that will be used as a temporary to hold the buffer, to hold this new combined buffer before returning. So if the buffer is not empty, meaning that this buffer A has stuff in it, first want to check if it's full. And if it's full, then just copy everything over. Else, if it's not full, then you want to copy using the write command to make sure that that everything is sequential. You want to write everything up to but not including the write pointer. And for buffer B, you want you the same thing. So let me try to illustrate this. Let's say there's 1, 2, 5, 7, and this is A, and this is B. Say that the right pointer is here, there. So for copying these two over, we have the value 1 is here, 2 is here. So for buffer A, we'd say, all right, copy everything up to the right pointer, but not including it. So stop here. So we'd say, all right, copy this 1 over, write the 1, and then move on to buffer B. Write everything up to, but not including the right pointer. So write this, and then stop. 5 and 7. And then everything here would just be 0. Whoop. And then once that's done, return temp. All right.
I have a question on that one.
Sure.
Why do you just neglect the where the right pointer is at, the value that's right there?
So the way
2 and 3 in this case.
So circular buffers are. This is actual computer science practices and data structures we're using here. So the way this buffer works, the way a ring buffer works, is the right pointer or the right head is pointing to something we haven't written to yet. So the idea is where this is pointing to, in theory, we haven't written to it yet. And the value that's there could be something we wrote there, but we've already read from it. So the idea is that where it's pointing to, we want to write to next, but we haven't written to it yet.
Oh, that makes sense. Yeah, because you want to if we were to go forward again, we rewrite or overwrite it. But in this case, you go to join the new one. That makes sense. Thank you.
All right. So, any more questions before I end the lecture today? And if there's anything you want me to explain about the assignment, more specifically, just feel free to ask, because it's best for me to answer these questions while I'm recording, and I can still upload the video to YouTube. Let me check that I'm recording. Yes.
Yeah, wait, so where do we have to again just keep track of where the right pointer is gonna be and then just put that there, or we just set it to the first row back? Or
so the way this works is where the right pointer is currently pointing to, wherever it's pointing to.
Yeah.
That's supposed to be something we either haven't written to at all, or we wrote to it and then we read the data from it. So when we read from something, even though we don't like erase it or set it to 0, if I were to read this 3, like read and return this 3 and say, all right, move the read pointer up to here or whatever, that's me saying, I'm not going to overwrite this 3, but treat this 3 like it's become garbage. Treat this 3 like it's been removed. And so the right pointer being here, pointing here is saying, treat this like it hasn't been written to yet, and we're waiting to write to it. So when we do write to it, we'd say, all right, write like a 4 here. Like overwrite this 3. Write a 4. And then move this forward. That's why we don't include, when we copy over data, we don't include what the right pointer is writing to.
Okay.
All right. Any more questions before I shut down the recording and the lecture and just start taking tickets?
So will all these functions be in the header file?
Yes, because of the way that template classes work, all the functions will have to be written in the header file.
Okay, so like even the constructor and destructor.
Yes.
Okay.
They'll be written in the header file, but not actually inside the class declaration.
So like at the like below the class declaration.
So it'll be like class our buffer, and then there's all the stuff in there, the variables and member functions of the buffer, and then here is where the actual functions would be written and then coded.
So it would be like if we were writing them in an implementation file, we're just doing it at the bottom.
Yes.
All right. Thank you.
All right. Any more questions? All right. Thank you for coming to my lecture. I hope this explains the assignment and I hope you understand a little bit more about pointer arithmetic. Let me end the recording.